Welcome to this video on what's new in Vivado Design Suite 2017.1. There are a number of enhancements in Vivado 2017.1, and this short video will cover some of the highlights. Vivado 2017.1 Design Suite is now supported on new versions of Red Hat, SUSE, CentOS, and Ubuntu operating systems. Additionally, it is important to note that 32-bit OS support has been discontinued for all editions, including Lab Edition. Please refer to the 2017.1 release notes for supported versions. Now in production are Zinc UltraScale+, MPSoC, Kintex UltraScale+, and Vertex UltraScale+ devices. In addition, UltraScale+ devices are now enabled in Webpack, and Spartan 7 devices are available for public access. In 2017.1, there are changes to the installer to support smaller disk footprint of installation images. We have accomplished a reduction in the size of the installer by disabling the installation of ES or engineering sample parts by default. Since the ES devices account for 12 gigabytes of data, not downloading provides a huge saving on space. We now support the ability to archive the downloaded installation image to allow for easy storage and moving. Please reference the 2017.1 release notes for more information. In 2017.1, we are introducing a new look and feel in Vivado. The motivation behind these changes are aimed at improving the user experience by simplifying the icons, improving readability, standardization of toolbar locations, tab locations, and settings. Because much of the code the Linux GUI is built on is no longer supported, being able to reduce development effort towards OS customizations will allow us to spend more time on features. As part of the new look and feel, we merged the project settings and user settings into a single, searchable dialog box. We also added the capability of previewing the text editor changes before applying them, and finally, we've migrated away from the vivado.ini file to an XML format. These changes should be transparent to the user and will allow us to maintain more complicated structures than the key value pairs we are limited to today. All current user settings will automatically be migrated to the new XML format, so if the XML file exists, the ini file is ignored. Additional changes to the GUI include the Add Sources dialog box has been simplified to reduce the possibility of adding duplicate design sources to your project. We've consolidated DSP, block designs, and IP into Add or Create design sources. When you add a directory, any design sources that are consumed by the block design are added first, followed by any additional IP along with their contained design sources, and finally RTL sources. This should ensure that IP contained in block designs is not added to the project twice. Partial reconfiguration licenses are now included in all System Edition and Design Edition seats. Also, the price has been reduced for Webpack Edition users. In 2017.1, partial reconfiguration includes the ability to set IP within reconfigurable modules and the ability to debug reconfigurable modules. For this, you need to instantiate a debug bridge in every reconfigurable module. Device support has been enhanced to include more UltraScale+ parts. The support list has been doubled for partial reconfiguration and Tandem flows. There are also new Tandem IP features in the UltraScale+, including DMA core support. In 2017.1, there is additional FPGA mezzanine card support for 1 daughter card and 4 baseboards. Partners are working to add daughter cards to the Xilinx board store, but users will need to manually go there and download the files. There's also a new Zinc UltraScale+ configurable example design available in the example projects in 2017.1 that customers can access. Vivado 2017.1 now includes new features in the area of IP flows. IP caching has performance improvements where the tool intelligently works only on cacheable IP. Unified data modeling is when the file on disk is only updated when a save or tool flow invocation is done, preventing unnecessary updates. And IP XCI, XCIX files are now used for IP checkpoints instead of the design checkpoint file. IP Integrator now makes it even easier to leverage board awareness. From the IP Integrator canvas, board-aware input clocks can now connect from a single source to multiple destinations. Improvements have also been made to the module referencing flow, which enables users to take RTL and use it on the IPI canvas without going through the packager. The module referencing has been extended to support key Xilinx IP that customers might be using, such as block memory, debug cores, DSP48, and key math functions. AXI Designer Assistance allows the user to choose between AXI Interconnect and AXI Smart Connect, and now interface signals. In addition, user comments are also added to the IPI canvas and appear in the generated HDL. There are a number of enhancements in HLS. This includes support for math library functions, dataflow pragma loops, added functionality for co-simulation, and DSP block support enhancements. HLS has also been tuned to reduce unnecessary pipeline that results in up to a 15% reduction in flip-flops being used. There are a number of new updates to existing demos in System Generator. A new demo is an MRI image reconstruction with 2D FFT using URAM. Updated demos include 16 QAM demodulator, Coates loop carrier, and LMS adaptive equalization. System Generator now also offers support for MATLAB version R 2017A. The Processor Configuration Wizard now supports Zynq UltraScale+ MPSoC. The features include cache-coherent interface support, isolation configuration, save and restore presets, DDR configuration simplifications, and finer control of processor subsystem resources. Isolation configuration is the ability to define and isolate subsystems within the PS using Zynq UltraScale+ MPSoC's XMPU or Xilinx Memory Protection Unit and XPPU or Xilinx Peripheral Protection Unit. Simply speaking, you can inhibit AXI transactions between a master and slave based on the settings of the XMPU and XPPU. There are a number of improvements and enhancements in the area of synthesis and physical implementation in Vivado 2017.1. RTL synthesis now provides the ability to optimize the design using an instance-based top-down compilation approach. There are preset strategies to optimize based on area, performance, or routability, with additional logic optimization options that can be specified by the user. Additionally, inference of quad or dual adders onto DSP blocks, new attributes for power-optimized large RAM decomposition, and BRAM inference enhancements features are available. In static timing analysis, there's new support to allow renaming of auto-derived clocks, clock domain crossing waivers, enhancements to report exceptions command, and improvements in runtime through the flow. In the area of physical implementation, there are quite a few new features targeted at decreasing runtime and improving quality of results. We are seeing improvement in compilation times of up to 40% for UltraScale+ devices and up to 20% for UltraScale devices versus 2016.4 when using Explorer-based strategies and directives. There are also new features aimed at improved fan-out optimization in the placer by utilizing the Place Design Fan-Out option command. We're providing more fan-out optimization before and during placement when it can be the most effective for reducing delay and improving placement. In 2017.1, there are a number of new features to improve routability, results, and messaging. The new Report QOR Suggestions command that checks the design for certain problems that are preventing design closure and makes suggestions on how to fix them, and also generates ready-to-use XDC constraints and tickle scripts. New incremental compile analysis features for timing and cell reuse reports, and improve ease of use for Report Power and Power Constraints Advisor. In the area of simulation verification, we now have the production release of AXI VIP and Zynq 7000 VIP, or verification IP. The AXI VIP that is designed in System Verilog supports AXI 3, AXI 4, AXI 4 Lite, full protocol checking, implements ARM-based license assertions, and is license-free. 2017.1 includes example designs and test benches delivered in the IP catalog to assist the customer with implementation and migration. The Zinc 7000 VIP that replaces the Zinc 7000 BFM is now available in 2017.1. It is built on top of the XI VIP and is license-free. It is delivered as an output of the processor configuration wizard and supports functional simulations of the PS to PL. Enhancements in the area of simulation flows include System Verilog and System Verilog package libraries are now recognized when launching or exporting for Vivado Simulator and Questa Sim. We also now provide the ability to generate MEM files from ELF files directly from the Update MEM tool. This is very useful for verification engineers where they don't need to run through Vivado and instead they can take a new ELF file from the software engineer and quickly see the impact of that in simulation. Also in simulation flows, there's enhanced tickle script handling to allow using pre- and post-tickle scripts in the simulation environment. 2017.1 also includes new productivity features for Vivado Simulator. Debug enhancements include the ability to set breakpoints inside subprograms, including tasks and functions, and can be executed in step mode. In addition, the waveform viewer now allows searching for values, a useful feature when analyzing simulation results. Now switching gears to hardware debug, as there are many features that have been added to increase productivity. System Debug in IPI now supports viewing of AXI transactions at runtime in the waveform viewer as shown here. There is also improved flow from IPI to bitstream, including enhanced design assistance in the IPI, and the ability to show the system ILA debug window post-synthesis. Other features include support for using Xilinx Virtual Cable over PCIe for design debug. Xilinx Virtual Cable, or XVC, over PCIe helps applications that require a robust and easy-to-use solution for debug. Remote debugging capability is especially important because there is usually no easy access to the target boards. There is a complete hardware design provided in the PCIe example design. Also in hardware debug, iBert now offers support for bathtub plots, including 1D and 2D versions. Additionally, memory calibration debug support has been added for LPDDR3. Also, there is new GUI support for creating SVF chains for Xilinx and non-Xilinx parts with the ability to import previously created chains. So in summary, Vivado Design Suite 2017.1 contains new device and OS support, Xilinx verification IP for AXI and Zinc 7000, the ability to debug over PCI, partial reconfiguration project-based support in IDE, and faster implementation compile times when using Explorer directives. Please review the Vivado 2017.1 release notes for more details on all the features and enhancements. Contact your local Xilinx representative today for more details on Vivado Design Suite 2017.1 or go to www.xilinx.com/download to download and install it today. Thanks for watching.